Hello everyone. Today we will discuss the basics in electrical networks. Electrical network or electrical circuit analysis. Here first we will talk about what are the methods are in the unit 1. First one is source transformation, source shifting, which will both will comes under first method, and second one is star delta or delta to star conversion to simplify the circuit. Next one, these are equation based simplification methods, nodal analysis, mesh analysis, little bit extension of concept of super node and super mesh. Before starting to the actual topics or actual methods, the first method, source transformation, source conversion, source shifting, this is circuit simplification method, because no need to write any equation, only we have to simplify the circuit. And star delta conversion, more equations are like we have to simplify the network. Nodal analysis, equations we have to write. Mesh analysis, equations we have to write. Before that, just we will see, we will brush up with some fundamentals. Now, in electrical networks, we have basically two types of elements. First one is active active elements, and the second one is passive elements. Active elements also we will refer as sources, specifically active sources, and passive elements we will often refer as RLC elements. The symbol for resistor, symbol for inductor, and for the capacitor. Now, if I know the resistor, depends on the current direction. If this is my current direction, the polarity will be this is positive and this is negative. If I take, for example, one more resistor, I will take. If my current direction is opposite, this is also same resistor, depends on the current direction. This is positive and this is negative. Now, if I want to write what is the voltage across the resistor is I into R, where I equal to V by R. Similarly, for an inductor, will represent with L, Henry's. If I want to know what is the voltage across inductor is L into di by dt. From here, I, if I want to calculate 1 by L integral V dt. If I have a capacitor, if I want to know what is the current, I is equals to C times dV by dt, and V is equals to 1 by C integral I dt. Generally, in first unit, we will go for only resistive circuits. We have to know what is the voltage across inductor and what is the voltage across capacitor. That will be helpful for AC circuit analysis, and as well as from the third unit. Now coming to the active sources. Basically, these are classified into two types. One is dependent, dependent and independent. Dependent, dependent sources, independent sources. What are independent sources? Independent sources again classified into voltage source, current source. Again, this voltage source again classified into two types. One is ideal voltage source, ideal voltage source, and practical voltage source. Practical voltage source. In case of current source, same way, we have ideal current source and practical current source. Practical current source. Now, how we will represent the ideal voltage source or ideal current source? These are ideal. Ideal means there is no resistance. Generally, for DC voltage, we will represent this is the positive terminal and negative terminal. Represent with V, or you can represent this is also one of the representation. In case of AC, here you will get this is AC source. Now these are ideal voltage sources. Ideal voltage sources because there is no resistance connected in series to the voltage source. Coming to the ideal current source. Ideal current source. Same way, we have the direction of the current. This is the general representation of a current source. If sometimes they may represent for AC circuit, they may represent like this also. Now, this is the current source representation, and these two are ideal sources. In case of if I want to know what is the practical source representation, practical sources, how we will represent the practical sources. For voltage source, you have to connect the resistor in series. Remember that if I have a voltage source, I have to connect the resistor in series. If I have a current source, I have to connect the resistor parallel to that. These two are practical voltage. This is voltage source, practical voltage source. This is practical current source. These are these notations, representation is very important. That's why you have to be carefully follow that. Next, coming to the dependent sources. Dependent sources. In dependent sources, we have four types. First one is I have first we will represent the dependent sources with a diamond symbol or we can say rhombus. Now here, if I know this is a voltage, generally we know that this is a voltage source. But because of this diamond shape and you can assume that this is a, I mean it is not assumption, it is, we can confirm that it is a dependent source. But depends on what quantity. We can write here alpha into I. If you write this is a basically a voltage source but depends on current. I will say that current dependent voltage source. That means voltage source depends on current, or you can write current controlled voltage source. You can write dependent voltage source or current controlled voltage source also you can write. Now, if I draw like this, if immediately you can say that this is a voltage source. If I write beta into V, now it is a voltage controlled, voltage controlled voltage source, voltage controlled voltage source or voltage dependent voltage source. Now you just guess it what it is. It is a current source, depends on voltage, depends on voltage V. So I can say that voltage controlled current source. Now, if I have a current source, which is some depends on some current. Now we see that what we can represent, it is a current source basically, because inside of that we have a current source symbol. It is basically a current source and depends on current. You can say that current controlled, current controlled current source, current controlled current source. These are the four dependent sources we have. So whenever if you saw that the symbol plus minus, it is a voltage source, and arrow mark if you saw like this, it is a current source, but depends on what quantity. That you can see here, alpha into I, beta into V, gamma into V, delta into I. So depends on what quantity. You can name the active component. You can name the dependent source. Now, so as already we saw that, we know we have two types of practical sources. One is practical current source, practical voltage source. So now we have practical voltage source, that is a resistor is connected in series to the voltage source V and R, and or generally we will draw like this. Instead of this, you may notice here like this is V and this is R. Now this one, if I want to convert practical voltage source to practical current source, if I convert practical voltage source to practical current source, the resistance will be same. Whatever the resistance is there, the resistance will be same. If I want to know what is the current, this voltage by resistance V by R, this voltage and this resistance, you can say I is equals to V by R. So this conversion we can do. Voltage voltage source with a series resistor, we can convert to current source with a parallel resistor. Sir, I have a current source with a parallel resistor because it's a practical source. If I want to convert to a voltage source with a series resistor, you can convert. This V is nothing but this I into R. V is equals to I into R, and this resistance will come same. That means when you are transforming or when you are converting practical voltage source to practical current source, the resistance will be same, and the current or voltage we can get by using Ohm's law. Is it clear, right? Now, this conversion we will call it as source transformation method, source transformation technique, or source transformation method, source transformation technique, or source conversion technique. Now, in this source transformation technique, a voltage source with a series resistor, a voltage source with a series resistor, you can convert into a current source with a parallel resistor. You have to understand both are practical sources. So the source transformation applicable only for source transformation applicable only for practical sources. Practical sources. Remember that. Now we will see. We will take simple example and we will solve this numerical. Now, just assume here I have one current source. Let us take problem number 1. Here I have one current source and a resistor. Here one resistor, here one resistor. Now, this is a very simple basic circuit. Now, I want to find what is the V naught output voltage across this resistor. Let us take, this is 5 ohm resistor and 2 ohm, 3 ohm and 4 ampere. So now this is a simple circuit which has 4 ampere current source, 3 ohm, 2 ohm, 5 ohm. Now after, if you observe the network or circuit, immediately how to identify it is the given source is practical or ideal. The source is practical. Sir, how you are telling it is practical? Because there is a current, so there is a resistor parallel to the current source. So now I can apply the source transformation. And one more thing, you should not disturb this where they're asking you to find voltage or current. That branch, no, don't disturb this branch. Just keep it till the end. Don't disturb this resistor. You have to keep till the end. Now, I can convert this 4 ampere with parallel resistor. I can convert it to a voltage source with a series resistor. Now, whenever if you put a dotted line, you just draw once again separately what component you are drawing. You are simplifying. Now, in this 4 ampere and as well as 3 ohm. Remember, whenever you have the current source to voltage source transformation, remember that arrow mark, these two arrow mark, whatever this one is there, no, this one always represents the positive terminal. Now current is going upward, so that is up one is positive terminal, below one is negative terminal. Over. Now that resistance to connect will series. Now I told same resistance will come here. This will become 3 ohms. Now what is the voltage? V is equals to I into R, that is 4 into 3, 12 volts. 12 volt. Now this is called source transformation. Now this I will substitute over there. Sir, how to substitute that? In the place of, you can see that arrow mark, upward arrow mark, you have to, your voltage source positive terminal should come. So this end you have to connect it to there. So this end you have to connect it to here, and this end you have to connect it to here. That is the thing. So now I'll draw. Actually, you should not draw on the same. To understand, I drawn that. Now here is my resistor, and this is the voltage source, and here is one more resistor given, like this is 2 ohm, this is 3 ohm, and 4 amp. This is how much? 12 volt. This is 12 volt, 3 ohm, 2 ohm, and I told that don't disturb this 5 ohms. 5 ohms. Here it is V naught. Now, only one step we have done. Now, no need to do any simplification, further simplification, because we know that two very important formulas. One is current division rule. Current division rule. If two resistors are connected between, if two resistors are connected parallel, if two resistors are connected parallel, if the total current is some current source is there, just assume like this. If I have some 5 ampere, if two resistors are connected in parallel, R1 and R2, if I want to know I1, if I want to know I2, if I want to calculate I1 is equal to total current into, if I want to calculate I1 means what is the opposite resistance? R2. R2 divided by total resistance is R1 plus R2. Now, I2 current is the current flowing through R2 resistor. Remember how to find that? Total current into opposite resistance. What is the opposite for R2? R1 divided by R1 plus R2. Now, this is about current division rule. What is voltage division rule? Voltage division rule. Now, I have a set of resistors connected in series. The total applied voltage is V across R1, across R2, across R3. Now, if I want to know what is the voltage across R1, that is V1 I will take, across R2 I will take V2, across R3 I will take V3. If I want to take V1, V1 is nothing but total voltage into what is the voltage across what is the resistance across V1, that is R1. R1 across R1 we taken the voltage is V1. So same resistance divided by total resistance, that is R1 plus R2 plus R3. If I want to calculate our V2, what I need to do? Total voltage into R2 divided by R1 plus R2 plus R3. Now you write the formula for V3 and you write on your own. And now you check with this what I'm writing. V is V into R3 divided by R1 plus R2 plus R3. This is your voltage division and current division rule. Now, for this circuit, if you see that 3 ohm, 2 ohm, 5 ohm connected in series. Now, how to find the V naught? V naught is equals to V naught is equals, how to find that V naught? Total voltage is 12 volt into same resistance. Where I want to find the voltage? 5. So 5 divided by total resistance, that is 3 plus 2 plus 5. I will get 12 into 5 divided by 10. 5 ones, 5 twos, 2 ones, 2 6. You will get 6 volt is your answer. That is your answer. So now only we have to write at the final, we can able to write the equation. Till that we have to do circuit simplification. Now next, second problem. If I have a circuit, a simple circuit only we will solve. Later we will move on to the some complex circuits. Let us take 10 volt, 3 ohm, 5 ohm and 6 ohm. Now I want to know what is the voltage across 6 ohm. Let us take, I want to know what is the voltage across 6 ohm. Now remember, I should not disturb the 6 ohm resistor since I have to calculate the voltage over there. Now you have to see that is there any practical voltage source is there or practical current source is there. In this one only voltage source is there. So practical or not, you have to check. How you are going to check practical or not? If there is any series resistor is there, yes, then it is a practical. Yes, in this problem the given resistor and as well as the voltage source combination is practical voltage source. So now you draw it separately. This is 10 volt and 3 ohm. This one I will convert to current source with a parallel resistor. What is the resistance? 3 ohm will come over here. 3 ohm. Now remember the direction of current. Where is the positive terminal here? Positive terminal located on the top. Right. So the current will go to upward. If if the positive terminal is below, then the current will go to downward. Right. Now what is the current? Current I is equals to V by R, that is 10 by 3. 10 by 3 ohms. Sorry, 10 by 3 amperes. Now you have to keep what is 10 by 3? 3.33 amperes. 3.33 amperes. That is the current. Now you substitute the same thing over there. How can I substitute there? Here, the current source with a parallel resistance of 3 ohms. Current source is 3.33 amperes, 3 ohms. And here it is, I'm not disturbing that 5 ohm resistor and 6 ohm resistor. I have to find the voltage across 6 ohm resistor. This is my V naught. Now, if you see that I should not disturb the 6 ohm. Now 3 and 5 connected in parallel. So now you can write that 3 ohm is parallel with 5 ohm. You can write if R1 R2 is parallel, what we can write R1 into R2 divided by R1 plus R2. So now 3 into 5 divided by 3 plus 5, 15 divided by 8. 15 divided by 8. So that you have to substitute over here. So now 15 by 8 ohms. This is R1 is 3 ohm is parallel to 5 ohm. Let us take some R equivalent. Now this will become a current source of 3.33 amperes and a resistance of 15 by 8. Calculate 15 by 8 how much it is. 15 divided by 8, you will get 1.875. 1.875 ohm, and 6 ohm is the one more resistor where I have to find the voltage. Now, if I want to know voltage, first I have to find how much current is flowing. Let us take, this is the current, let us take some I1. So now this is, let us take I2. Anyway, I'm not going to calculate I2, which is not required. So just I will calculate I1. How to calculate I1? Total current 3.33 into opposite resistance. I'm calculating the current at 6 ohm. That's what opposite is, 1.875 divided by 6 plus 1.875. You will get 3.33 into 1.875 divided by how much? 6 point, sorry, 6 plus 1.875 means 7.875. 1.875 divided by 7.875. 7.875 into 3.33. If you do that, you will get I1 current is equals to 0.7928 amperes. 0.7928 amperes. So this is your current flowing through 6 ohm. But the question is asked, what is the voltage across the 6 ohm? So what is the voltage? Voltage is equals to I into R. So what is the current? I1 into 6. 0.7928 into 6. You will get approximately, you will get 4.757. 757 volts. So this is the method you have to apply while calculating the source transformation method. Now, if I have a two sources, if I have two sources means a current source, a voltage source, both I will take. Now, this is 2 ohms, 3 ohm, 8 ohms, and 3 ampere, 4 ohm, and 12 volt. I want to know what is the current flowing through 8 ohm resistor. I want to know what is the current flowing through 8 ohm resistor. So I will draw the direction and current. I'm interested how much current flowing through 8 ohm resistor. That's why you should not disturb this 8 ohm under any circumstances. You should not disturb the 8 ohm resistor. Don't disturb this 8 ohm. Now if you observe that 4 ohm and 3 ampere both are connected in parallel, you can say that this is a practical current source. So 3 ampere and 4 ohms. It is a practical current source. What is the direction of current? Downward. This is 3 ampere. It is 4 ohms. Now, how to convert this one? Voltage source. A voltage source, the positive terminal is towards the ground side. Remember that. So positive side is towards the ground side. And the resistance. This 4 ohm resistor, you can write it over here. 4 ohm resistor. And what is the voltage? V is equals to I into R. So in this case, you will get again 12 volt. Now just substitute over there. Then the circuit will become, this is 4 ohm and this is 12 volt. Now, what is this resistance? 8 ohm. I should not disturb this because current is, I have to calculate the current. Now, you see that this 4 ohm and 2 ohm is connected series. 4 ohm and 2 ohm connected in series. Now, 4 and 2 connected in series, what is the equivalent resistance? 6. And one more side, if you look at this side, I have a voltage source and this is 6 ohms and the voltage source value is 12 volt, resistance is 8 ohm, whose current is I. This is 12 volt and this is 3 ohms. Now, again, is there any circuit simplification is possible? Because is there any source conversion possible? Yes, because voltage source with series resistance is there. In this case, if you observe, this is voltage source with a series resistor. This is also voltage source with a series resistor. Don't think that, sir, one place you were drawn like this voltage source, one place you drawn like this. Either is there difference? No, both are same. Both are same. In fact, I will follow only one notation. So what I will do, this one, I will write it. This is negative terminal and this is positive terminal. Now, I have negative terminal and positive terminal, and here is the resistance. How much it is? 12 volt and 6 ohms. How to convert the current source? Here is the current source whose direction depends on the positive side of the voltage source. Positive side is downward. This will be downward and a parallel resistance. Now what is the current? Current I is equals to V by R. So 12 by 6 is 2 ampere. What is the resistance? 6 ohm. Resistance is 6 ohm. There is no change in resistance. Similarly, on your right side also there is 12 volt and 3 ohm is there. That also we will simplify. What is the equivalent current source? Current source direction is upward or downward? It is upward because positive terminal is upward direction. You can remember in that way. And 12 by 3 is 4 volt. And series resistance will be same as your given resistance 3 ohm. Now if you substitute over here, these two are connected, it should be connected in parallel, no? So 4 amperes. This is 4 ampere current source, 4 ampere current source, and a parallel resistance is there. What is the resistance value? 12 by 3 is 4 ampere. And what is the resistance value? Same value here, 3 ohms. Substitute over there. How much you will get? What is the circuit you will get? One current source which is downward direction with a parallel resistor 6 ohm. This is 2 ampere, and 8 ohm you should not disturb till the end. And you have one 4 ampere current source which is upward, and a parallel resistance of 3 ohm. This is what you are having your circuit. Now, as we have to find the current through 8 ohm resistor, don't disturb the 8 ohm. Remaining, if you observe one thing before solving this, you have to know that if two current sources, one is upward, another one is downward. See that if both two current sources are connected in parallel, let us take I1, this is let us take I2. If both are connected in opposite, then you will get the current I1 difference I2. I1 difference I2. That means, for example, if I have some 5 and 3, some 5 ampere and 3 ampere is there. So this is some 5 ampere and this is 3 ampere. Now what is the resultant current source direction? Which one is higher? 5. 5 minus 3 you have to do. 5 minus 3 means upward direction 2 ampere. Remember that. Now if it is in the same direction, either upward or downward, if it should be same direction. So this is 5 ampere and 3 ampere. So if it is same direction means you have to add that. So the direction of current will be same like 8 ampere. You have to write. So this is what about your, if current sources connected in parallel, like that you will get. Similarly, voltage sources also connected in series. If voltage sources are connected in series. Sir, current sources means arrow mark is there. For voltage sources, how can I tell that? So now you have to travel in one direction, either upward to downward or down to upward. So now when you are crossing the each terminal, first voltage source is 10 volt. Which one you are touching first? In this direction you are moving is positive terminal. And next one, if you are crossing here, you are getting positive. So that means both are having same polarity. The equivalent voltage source will become 30 volt. 30 volt. Now, for example, if I have 10 volt, this is 20 volt is there. 10 volt and 20 volt. If both are, if you observe, this one when I am coming here, first I will strike this positive terminal. And second source I'm striking negative terminal. That means you are having opposite polarity. Which is higher value, that polarity you will get. 20 volt is higher, that polarity you will get. The difference between the two is 10 volt. So this is about two current sources connected in parallel. Now same based on this, if I come to here, 2 ampere is downward, 4 ampere is upward. So then tell me what is the resultant current direction, upward or downward? It is upward. What is the value? 2 ampere. and 3 ohm, 6 ohm, 8 ohms. So now you can write it here. Current value is upward to 2 amperes. You have 3 ohms and 6 ohm and 8 ohms. As we know that we should not disturb 8 ohm, we can disturb 3 and 4 are connected in parallel. I can write this one as 3 and 4, 6, sorry, 3 and 6 parallel, 3 ohm and 6 ohm parallel. You will get 3 into 6 by 3 plus 6. You will get so 18 by 9, 2 ohms. So now here you will get 2 ohms. Here you will get 8 ohms. This you will get 2 ohms and here you will get 8 ohms. The current is 2 ampere. Now, if I want to know what is the current flowing through 8 ohm, that is what I want to find now, Ix or current I. If I want to know current flowing through 8 ohm, you know that current division rule. What is the formula? Just to recall, total current into opposite resistance. What is the opposite for this 8 ohm? Our 8 ohm opposite is 2. 2 divided by 2 plus 8. You will get 2 into 2 by 10. You will get 0.4 amperes. So what is the current flowing through 8 ohm resistor is 0.4 amperes. So like this, you have to apply the source transformation method. Source transformation, what we have done? Whatever the circuit we got, first, is there any practical sources are there? Practical sources are there, we have to convert that.